Now let's look at what it's like to write the same program in a language that doesn't have its own built-in parallel programming model. Like, for example, the C language, in which case we'd have to link to a parallel programming library like the message passing interface, MPI. And right away you can see that there's a great reduction in complexity, even just in the size of the programs. So what we want to talk about is some of the reasons why that's happening and how it happens. This code that I'm showing in C comes from an Introduction to Parallel Programming by Peter Pacheco, published in 2011. The C program starts up several MPI processes. Each process creates a greeting and sends that greeting to the process of rank 0. The rank 0 process receives the greetings from the other processes and also creates its own, and then prints out all of the greetings. This program is 32 lines. It has 3 file dependencies, 5 constants or variables that get defined. It calls 6 procedures external to the language. Those, of course, are the MPI procedures, and passes 19 arguments to those procedures. Has 2 conditional branches, if and else. If you compare that to the Fortran program, we can see that we've reduced the number of lines by more than half, reduced the number of variables or constants declared by 40%. And what's really nice is in some categories, we've not only reduced the complexity, but actually completely eliminated the complexity. We have no procedure calls external to the language, and we therefore pass no arguments. We cut the number of branches from 2 to 1. That's because of the one-sided communication, where we can just go out and grab the data from the other image on the fly inside the print statement. And we have no file dependencies. The reason for that reduction and, in some cases, elimination of complexity is that because the parallel programming model is built into the language, that means that we can take advantage of all the knowledge that we have about the types so that we don't have to pass additional information about types like we do with MPI, and about the size of the data structure, so we don't have to pass that kind of information. So hopefully it's clear at this point that Fortran illuminates a very simple path towards parallelism.